thank you for all that data. Like I said, it looks like 3 out of your 4 year lessons had mastery go up. That's awesome. So what are some of the things you've been doing there that you think are the most successful in your reteach lessons?
I think the big thing is, I think I've said it before, but like focusing in, when you look at it, you focus in on like what's the one thing that we're missing, because you get a lot of change without having to redo everything, and that's, sometimes my instinct is to redo it, so picking the one thing that's going to get us the most change with the littlest amount of time.
Awesome. I think that's the exact thing I would say has improved in your practice from last semester to this semester. You've always been somebody who responded to data, but now you're zooming in and closing those gaps. So, all right, let's talk about this Hess's law problem. So I have your exemplar right here. Just walk me through what are the keys to an exemplar response. We're going to root ourselves in that before we look at some kiddos' work.
Okay. So they're looking to, like starting with the first equation, they're looking for similarities or compounds in common between these equations below and the one sort of interest. And then deciding how are they going to, we've been using to manipulate the equation, either multiplying or reversing it or both. So they're looking for one thing. So in this first one, it's this OF2 compound. They want to double it in order to match the coefficient. And then the second thing is anything they do to that reaction to make sure that they're doing it to enthalpy before they put it down below. And they move through the equations. The last one we've been focusing on, if you can't match the top, then trying to figure out what compounds are not included in there that we need to eliminate, and how do we get them onto the other side. And then in towards the end, they're cross-eliminating anything that's on both the reactants and product side to basically recreate the top equation, and then they're adding all of the enthalpies for those equations to get their final answer.
Great. And there was actually only one kid who didn't do that last part, which was pretty cool. Everyone, I think it was like came on it too, so it was a small mistake, but everyone else really got this. So you named a lot of it, but what are the thinking steps that students have to take just to, before they even get to here?
I think just, sometimes it's hard to describe, but the idea is just like, what in this first equation do I even recognize as being similar to the top one? And trying to isolate that one thing and focusing on one compound to change, as opposed to how do I change this whole reaction to get it to work for me. And the other step, and I noticed it, I can tell with the mastery getting better over the course of the day, the other step I think that I didn't emphasize enough earlier is like, if you have two different compounds that are in your first reaction, to work with the one that you only see in one place, so you don't throw off your reactions.
Okay. So I noticed on your exemplar and on the one for the Unit 5 test that there are annotations for those. What's the significance of having those annotations?
I think one, we can see what they are doing, or especially if they miss over here, we can see what they were thinking. And then I have been telling them that the annotations also help with just making sure that you're also doing, whatever you're doing in the reaction, it's easier to keep straight that you need to do it in the enthalpy too.
Right, and what's the impact if they don't do an annotation like in the unit test or here? What's the impact on their work?
I think it's just easier to get confused, especially if you don't write the enthalpies down early. You might forget to change the sign or forget to double it if you don't have like something to come back to as to what.
Exactly. So definitely something that it's good that you did on your exemplar, and one of the stamps that they have to do on the test or they're going to make that same mistake. So let's look at this first stack of work, and what's the gap between these kiddos? What's the very first gap you see in terms of sequencing of work and yours?
So they all miss the second equation, and then because they didn't reverse it, they have the enthalpy sign is negative instead of positive.
And what's missing from their work that shows you that? You labeled it on all of them, so it's kind of easy to see.
Right, but they didn't reverse this equation.
Great. And they didn't make a note for themselves at the very least. Okay, so that's the first one. Now what about this stack of work? What's the gap between these kiddos?
We'll come to this, just 1 second. So some of them are missing the last equation. Some of them are just like not recognizing that they need to double it, but some of them are recognizing that it gets doubled and then not doubling the enthalpy.
So this kiddo's maybe not a good example because Justin actually did annotate it, but if you look at all these kiddos, they're not annotating either.
Right. So for this one, like he's annotating, but I feel like he's just like missing, and this one has it. I think they're just missing that you need to do it.
Yeah, I didn't notice, you know what I did? I saw purple and thought that was your pen, but it wasn't your pen's the red one, so
Where's
you
my
did
pen?
too.
Like, one second.
My bad stack of work. But let's go ahead and stamp it though. So thinking back to these kiddos, I think these are the most clear. I want you to complete a sentence. Students are not accurately calculating delta H because they are not what? That's the very first thing they didn't do.
They just didn't reverse that equation.
Great. And I even took that even simpler, and I said because they're not annotating coefficients or reverse reactions before solving. So it's not necessarily coefficients. What would you say for that one? That two piece, what do you call that?
They're not multiplying, I mean,
The reason why I said coefficient is because of this, but
I feel like this one's different, right? So I feel like a lot of them, the multiplying the equation comes more naturally conceptually than the idea that, right, so none of them wanted to change it.
this is definitely the most frequent gap. So let's go with this one. Students are not accurately calculating delta H because they are not doing what in the stack of, in this work?
They're not recognizing when they need to reverse an equation.
Great. They're not recognizing, let's write that down. They're not recognizing when they need to reverse an equation. Awesome. You have the gap on your paper. Students are not accurately calculating delta H because they're not recognizing when they need to reverse an equation. Okay, so let's talk about reteach. I think you have a lot of samples here where there's just one clear gap and you have a clear exemplar. So what do you think is the best method for reteach?
I think this one could be pretty easy to put on the board and just have them recognize the difference between, like we only have to go back and get to this step as opposed to remodeling the whole thing.
Right, so definitely I think a discourse. So if you, where did your exemplar go? Where did I put it? Oh, it's on here, you're saying. Right, so if you put up your work and the kiddos' work, go ahead and take some time on the back, or if you think you can fit it here and script out what your questions for discourse would be. And don't forget the question at the end, have them stamp the key idea.
Let's see. So I first just asked them to take a look at and find the difference between the two of them, and then just talk about which one is right. or which one they think is right. I think that will come pretty naturally when they see the way it crosses out. I think the
Which work sample are you gonna use for this? You're gonna use your exemplar and then which kiddos work?
It's tricky because I marked them all
You can put it out.
I would end up, of these ones, I would end up picking whoever's handwriting was the clearest and biggest for them to see, I feel like, because they're all making sort of the same mistake. So John's might be a good one.
Okay.
I think the big question.
Can you ask the question how you would ask the kids so I can hear what it sounds like?
So between these two examples, which one, I would just ask which one's gotten us to the correct answer to start. And then I would ask them to like zoom in on which reaction. So which reaction is the difference between the two of them? Usually I say like take a look right here, so I'd have them discuss which one is right and then zoom them into where it is.
Why not ask from the start, between these two samples, which one accurately gives the right answer and why?
Okay.
What's the impact of just asking that from the start?
They probably have to do more, they probably have to look at it more closely to figure out the difference.
And in terms of management, you don't have to like call them back a couple of times, it's just one question. So let's go ahead and capture that question in your paper, so you might have more paper if you need it. So which one lands us on the right answer and why? What would be the ideal response to that?
I think for the why, ideally they'll be able to say like, in this one you're able to eliminate any compounds that aren't in the top equation to get the right one on the bottom.
And even before that, they could just say, the first one, remembered to reverse the reaction. So let's go ahead and record in there what your exemplar responses will be, so that way you know what you're listening for. And then the follow-up question to that is, how do you know when you need to reverse the reaction? I need a little script here too, that's why I was. And why is this the most important question you're gonna ask?
Because it gets to the sort of process, the thinking process behind how they're going to determine when to reverse.
Right, because we said that was the gap. Students are not calculating this correctly because they're not reversing it, so they need to walk away with knowing when to reverse it. So what is the ideal response to that question? Reverse the reaction when?
When you need to shift the compound from one side of the reaction to the other for reactants and products.
Great. And then my last question was, so then what's the key thing to remember? And then they would re-stamp it.
Okay.
So let's take it from the top again. You're about to do this with your kiddos, what do you say?
Just between these two examples, which one gets us the right answer and why?
And what's the ideal response?
That this one didn't reverse the second equation.
Great. And then what happens next in your reteach?
I would ask them like how they need to know, or when do they need to reverse an equation, how do they know it?
And what's the ideal response?
When they need to move something from the reactions to the products.
Great. And then what do you ask kids?
So what's the key takeaway?
Great. And what would be the ideal response?
That if you need to shift a compound from one side of the reaction to the other, that you need to reverse the equation.
Great. I understand why you do these scaffolded questions, but when you just put it on the front load, if you front load it, they're doing more of the thinking with their partners that way.
Yeah. I feel like in this one, and I'm asking, I feel like this is why they're confused. Like, does this matter to Zoo? So I think none of them did it because SO2 is already there. And so they don't think that they need to reverse this one because they see, okay, great, coefficient's the same, it's on the right side.
So you could ask them as a follow-up question, so like, how do you need to reverse it? What's confusing about this one that made us maybe not?
Okay.
So you can add in that question, what's confusing about this one that would make us think we might not? You need to show them a whole problem, like you can still stay on this one, but teach them all the nuances they might expect to see. All right, so what are the 4 questions you ask kiddos that you're gonna ask kiddos for this? What's the first one you ask?
Which one is correct and why?
What's the ideal answer?
That the second one did not, the first one is correct because it reversed the second reaction.
Okay, and then what's the next question?
How do you know when you have to reverse a reaction?
What's the ideal answer?
When you need to shift products and reactants.
Great, and then what's the follow-up to that?
So what's the key takeaway?
There was one question in the middle you just added.
Just like in reaction 2, what could be confusing about knowing when to reverse this reaction?
Great, what's the ideal answer to that?
That there are 2 different compounds that they see up in the first reaction.
Great, and then what's the last question you ask?
So what's the key takeaway?
Awesome, how is it doing in that sequence gonna close this gap of students are not accurately calculating delta H because they're not recognizing you need to reverse? How is that gonna close that gap?
I think the stamp makes a big difference. It's something that, so then it's like if we're gonna have a discussion, like to just summarize it and neaten it up at the end is like this is the reason why we talked about this and this is the main point.
Awesome. When can you reteach this? I just pulled up your quarterly plan. I don't know if it makes sense. Tell me your thoughts first and then I have a thought.
So today's lesson, I was looking at it last night and I do feel like it's a little bit short. Because we've been planning for 1 and leaving that space. So I was gonna come back for to redo, not redo it, but to look at exit tickets from Bond Energy, which is just a real quick one. But I do feel like we have time in today's lesson to add in a quick, I think we could do the discourse for Hess's Law today.
Okay, when could you reassess it though? Do you have time for that today or no?
Let's see. I have right now.
But my other thought though, instead of maybe squeezing it in, is you don't need to have Hess's Law to do the next couple, you don't need to understand Hess's Law to do the next couple of lessons, like in Shatley's principle and effects of reaction, and then molecular collision theory, you don't actually need to do that. So you could do this on your review day.
Okay. Yeah, I think that works. They're not gonna meet it through any of that stuff. Great.
And then do an exit ticket. I would still do an exit ticket that day, even though it's a review day. I would do this question and one maybe with an energy diagram, so that way if there's anything quick you can do the next day that you do before the test, it's worth it.
Okay.
So I'm gonna add a note in your quarterly plan to, after do now, or as the do now, I'm just gonna put include Hess's Law discourse. I think in this case, rather than trying to cram it in today, you know it's something that's like, what is it, like 6 or 7 points on the test? And it is a gap, so it makes sense to close that before the test isn't necessarily needed immediately closed. 4 points. Sound good?